Hey, Jeannie,
Yeah, bro.
who's our guest on Energy Nerd Show?
Today we have Chris Van Dyke. Hey, Chris.
Oh, Chris, hi.
Hi,
Welcome to the show.
How you doing?
I'm good. Excited to be on the show. I was an engineer at Tesla for a long time, worked on the charging systems, but then also ended up working a lot in manufacturing and started a company that makes cameras that can kind of automatically recognize defects in factories. And so it's a technology we sell to manufacturers. Tesla was working on the self driving car program pretty aggressively, but that same technology was not really available in manufacturing. So that kind of seemed like an opening for a new company.
Are you responsible for this?
I worked on that. I was there on the team, working on that stuff.
That was like before there were EVs on the road. I mean, EVs go back, 100 years, but I'm thinking when this Tesla charging infrastructure was being designed, there were not a lot of EVs on the road.
I joined Tesla in 2010 and the Roadster was being made and it was maybe like 50 a month or something were sold. And so like there were maybe 2,500 sold all time and they were like halfway through that when I was there. But there was good tech and they were designing the Model S, which was the car that obviously sold a lot more and really kind of did bring EVs forward. And one of the big decisions that Roadster used this custom gigantic connector. And that was like the new car needed to have a much better connector. And that was one of the things I was hired to be a part of is that design of that connector.
What was the design challenge like? You're a young engineer at Tesla, and someone says, "Hey, we need a better charger." What do you got, Chris?
There were a couple directions we could go in. There were other car companies at the time trying to develop this standard, a standard connector that they would all adopt. And, Tesla spent a little time kind of like, oh, well, could we like work with this group? But the kind of goals of that group were very different. Tesla needed the fast charging capability, whereas all the other cars at the time were really only focused on the very basic slower charging. And so we sort of jettisoned from that very quickly. And then we're just going to do our own. And there was a big goal to make the connector as small as possible. And the thought there was smaller, it's lighter, it's easier to plug in. We really didn't want it to be a burden. It needed to be a nice thing. It's something you do every day if you have an EV and you have like the right setup. And so it should be as easy as plugging in your phone or your computer and not heavy and kind of awkward and hard to get it, into the car. So the goal of easy to use kind of like almost directly translated into the goal of small. Try to keep that interface as small as possible and then that'll like kind of ripple through as easy to use.
So, how do you make it small?
I like stared at it for like days and days and would like show people different things. And it's simple, it's only pins. And it's one of those things where it kind of seems simple at first and you can just do it. But if you really kind of stare, you can find some ways to make it smaller. So, one thing Tesla put AC and DC charging on the same charge pins. So, there's only 5 charge pins on that one, whereas some of the other ones, they have pins for AC charging and pins for DC charging. Your battery accepts DC charging, so you have to convert it. And so you convert it on the car. There's a little device that converts it. But because of that, you can only do a little bit at a time. DC charging is what you do for fast charging. You just dump the power directly into the battery. And so the car kind of needs both. You need the AC to have in your house, make it easy to charge at home, and then the DC for the road trip situation. So putting both the power on the pins makes that smaller. You then have to have some switches on the other side so that you're not putting AC power into the battery directly and you're not putting DC power into that AC conversion thing, that could kind of damage it. So that was one big thing. And then another piece that really made it a lot smaller was you can see the plastic that surrounds the bigger pins is kind of like morphed into the plastic that surrounds the whole connector. And it's just as kind of like rugged because it's that way. But a lot of the other ones, I think all the other ones have a ring of plastic around each pin, and then they have another ring of plastic around the whole thing. And that actually makes the footprint quite a bit bigger. Linking those plastic walls, that was where it was like I really like stared at it a lot and like thought about each little aspect. And I feel like the lesson I learned was like even when you think there's like nothing you can do to improve something, if you really focus on it, you think about it and you pick it apart, often there is something. Things that kind of seem simple, seem like they're at their conclusion, you can usually find ways to make them even better.
It's really small and the size is nice. the other thing people really, really care about is fast. So is it like, hey, Chris, make it smaller, make it smaller. And then over these, they're talking to the other guys, hey, Joe, make it faster, make it faster. And then Chris and Joe like had to bash heads. Or what does this have to do with fast?
It's a great question and good point. The size of the overall thing and the part that actually determines the speed are not nearly as linked as like you'd think. What determines the speed is those two big pins, the size of those, and the Tesla one is like 9 millimeter. And then that CCS one is 8 millimeter. This is the diameter. And so 9 millimeter diameter is quite a bit bigger than an 8 millimeter diameter. That did allow it to go even faster. And so even though we were trying to make everything small, we did keep those two pins pretty big. And then that allowed it to really perform well and still be small. Then there's other things you can do in the handle on the charging station side and in the car that can also kind of keep speed up, even though the interface is small. So there's a lot of like system-wide choices that were being made to make it go faster.
Is it gratifying to know that the big corporations are now in cahoots to converge on your design?
Yeah, it is satisfying. It's funny because it was something I really worked intensely on like 10 years ago. And at the time was often wondering, will this kind of like win out, and didn't really have any idea. And then it seemed for years and years to kind of like not really, move beyond Tesla. And it was always a good part of the Tesla charging effort and experience, but it is cool. I mean, it's not something I'd been kind of like thinking that much about, but like definitely proud of it, and it's satisfying.
Do you think it's going to be the standard for EV charging 10 years from now and 100 years from now?
I don't know. I think the things that could change it are you could end up with something more automated, and that maybe is like under the car, and so you get rid of that thing altogether. That would be probably in that 100-year, even maybe beyond 10-year time frame. I think it'll be around for a while. I don't think Tesla's going to move away from it. Now these other cars are moving to it. There are a lot of stations. That's a big part of this conversation. And then eventually maybe the cars get rid of the AC. They still have this like AC to DC converter. Because you have AC in your house, you need to have that converter. But if you had a DC charging station at your house, then you could get rid of that. If EVs really kind of proliferate, maybe that ends up happening, makes the car a little cheaper. And that might be another reason to change some of the connector. But I don't know, those things do stick around. So it probably will be around for a while.
There are a lot of people who are interested in two-way charging. If you think about like grid resilience or grid support, in terms of the technology, is that like a big lift?
That's kind of like independent of the connector. So kind of choices on the car, basically, and maybe the station, depending on how it's set up. But that really comes down to choices on the car's architecture as to whether or not you can do it.
But that's really good to know. It's not limited by the connector.
So we have the sun making DC up on our roof. Why can't we just put DC straight into the car?
You certainly can, but there aren't great commercial products for it. So I think the like DC on that solar panel kind of changes voltage over the day, and then it gets converted into some other thing. It's just not going to be the power that goes directly into the car. You could design a device, a power conversion product that would do panel into car, but it would actually end up being kind of similar to what happens where you chop the DC down into AC, then you put it back together into DC. There's just a lot of inertia around the kind of current AC that we have as like the baseline, and then kind of tying everything to that. So certainly possible, but not kind of commercially viable yet.
I'm wondering, do you think it's the industry standard because, why didn't the traditional American car manufacturers do, and is it because Tesla just rolled it out faster, the cars and the chargers, and or because they hired smart engineers who innovated that made it better?
Probably some combo, but we talked about the connector. I think it's better. It's easier to use. It's smaller. It therefore costs less. So there's definitely like value in using that smaller connector. But out of the gate, the other companies didn't want to do that. Tesla also, because they were so far ahead, and there was, discussion of like, should you partner with a charging station company? And that was also kind of like not really considered at Tesla. Tesla really wanted to control its own destiny and just sort of do its own thing and like be able to work at its own pace and not be kind of tied to, someone else's decisions. And so built this whole supercharger network as well, and built a good team of good engineers to kind of roll that out, and rolled that out, along with the cars. And it made the cars a lot more desirable because you could go on road trips. And that made the stations, used a lot because there were cars. And that probably was more of a pull. I don't really know why the auto executives made decisions that they did, but that's going to be more of a draw if you're trying to sell cars and they're actually able to charge at these tens of thousands of charging stations versus the other standard has some, but it's spottier and they're not as fast and there's not as many. So the coverage and the fact that you can charge at the faster pace with the Tesla one, I think probably the stations and that network of stations was a bigger draw, but it's a good combo. You get the easier to use handle, the lower cost parts on your car, and the access to the network.
So, Chris, do you now drive a Tesla and charge it at home?
I do, yeah. I have a Model Y. It's great. I charge at home almost all the time. The charge cable is really small. It's another thing we really push for. So that's nice because it means it doesn't really trip anyone's stroller or anything. And so we can just kind of lay it on our sidewalk. And in San Francisco, people are tolerant of, EV paraphernalia.
It's good talking with you. Really good to see you.
Yeah, it's fun.
Thanks for being on the show, Chris.
Sure.
See you soon.